Hello dear colleagues, we offer you a report on radioecological monitoring as a key factor in food quality management. After nuclear weapon testing and technogenic accident, more and more citizens around the world began to worry about the quality of food, content of heavy metals, radionuclide and other. As these radionuclides share some chemical properties with nutrients, plants and animals absorb them along with necessary nutrients for growth. As shown in Figure 1, artificial radionuclides migrate through the food chain. Radioactive cesium is washed out through atmospheric precipitation and enters the soil, substitute potassium in plants. This process is particularly significant for potassium-rich crops, which can result in radiocesium entering the human body through trophic chains. The result of the analysis shows that the problem we outlined is considered and described in the following areas: development and use of equipment for radioecological monitoring, use of monitoring data to solve problem of management of radiation-contaminated areas, study of radionuclide migration through trophic chains, peculiarities of functioning and regulatory and legal support of radioecological monitoring of food products. The aim is to analyze the data and compare the regulatory framework for food quality management within the framework of radioecological monitoring. France. Monitoring of radioactivity in food in France at the national level is carried out by the Direction Générale de l'Alimentation DGAL in cooperation with the Institut de Radioprotection et d'études nucléaires IRSN. The most important radionuclides tested are cesium-134 and cesium-137. The ISNA carries out additional analysis on the samples submitted to check for several natural and artificial radioactive elements. An example of 2018 radiation monitoring data visualization for food products in France is present in Figure 2. Spain. The Spanish Nuclear Safety Council, CSIN, manages the National Radiological Surveillance Network, consisting of automatic and sampling stations. This network provides information on the levels of radioactivity in air, water, soil, and basic foodstuff. You can see in Figure 3. A map with sampling station where food is collected, shown in Figure 4. Cultivated vegetables are collected at 16 stations in different farms. Intensive agriculture is carried out both in open ground and in greenhouses. The UK. The Northern Ireland Environment Agency monitors the long-range impact of liquid discharge from the UK's largest nuclear complex, Sellafield, into the Irish Sea. It is sampling fish, shellfish and indicator material from several locations along the coastline. You can see in Figure 5. The program to monitor natural and artificial radionuclides in crops in England, Wales and the Channel Islands as a check on general food contamination away from nuclear facilities was discontinued in 2014. Germany. Radioecological monitoring of food in Germany carried out by the Bundesanfangschutz in the past. Artificial radionuclides from the atmosphere have been deposited on plant and animal food in Germany following the Chernobyl nuclear power plant accident and atmospheric nuclear weapon testing. Southern Germany was particularly affected by the Chernobyl accident. The mixed diet of healthy adult is obtained by collecting samples of food and beverage served in the Pleasant prison in Berlin. An example of mixed diet sample is shown in Figure 6. Sampling is supported by the Veterinary and Food Surveillance Office of the District of Charlottenburg-Wilmersdorf, Berlin. Regular official monitoring of important foodstuff in Germany does not specifically check for radioactive contamination. Nevertheless, important goods may undergo inspection related to the Fukushima nuclear power plant and Chernobyl nuclear power plant accident. China. National Nuclear Safety Administration (NNSA) is improving the management of the National Environmental Radiation Monitoring Network. The NSA is providing recommendations to environmental protection authorities in all provinces, autonomous regions, and municipalities. The NNSA is also strengthening radioecological monitoring of the marine environment in connection with the release of treated wastewater from the Fukushima nuclear power plant in 2023. The geographical location and details of water and food sampling are shown in Figure 7. Ukraine. The State Service of Ukraine and Food Safety and Consumer Protection carries out radiation monitoring of the level of radioactive contamination of agricultural products and food by the legislation of Ukraine. All information on the level of activity of radionuclides in food in different regions of Ukraine is available on the website of this institution. The monitoring laboratories of the Ministry of Agrarian Policy and Food of Ukraine also carry out monitoring in place of concentration of radioactive substance in soil and food. The Ukrainian Research Institute of Agricultural Radiology, a structure unit of the Nucleus of Ukraine, deals with radiation monitoring of agrobiocenosis, including radiation monitoring of products in contaminated areas. Today, access to information on radiation pollution is limited due to Russian military aggression. In this study, relevant data from open source of information was collected and analyzed critically for each country. They compared the content of the two most common artificial radionuclides, strontium-90 and cesium-137. Which can be life-threatening as they can replace potassium and calcium in the body. These radionuclides are formed during the decay of uranium and are present in most parts of the world as pollutants. Table 1 shows their permissible levels of cesium-137 and strontium-90 radionuclides in different from food products in Ukraine, the European Union, China, and South Korea. Based on Table 1, we can conclude that Ukraine has the most stringent regulation on the maximum content of radionuclides in food. After analyzing the IAEA publication, we have completed a Table 2 that shows the permissible levels of radionuclides in food products in Ukraine following the accident in the Chernobyl nuclear power plant. It is worth noting that monitoring the migration of radionuclides and their impact on the population has enabled us to determine the maximum level of radionuclides contamination in food products and take preparation measures. This has helped in reducing the mortality rate among the population and livestock, ensuring a safer life for all. Conclusion. The comparison of the maximum allowable levels of radionuclides in food products according to the legislation of different countries revealed that Ukraine has the most stringent standards for the maximum content of cesium-137 and strontium-90. The author of a publication suggests that due to the significant delay, usually 3-4 years, in updating data on radioecological monitoring of food products, it would be beneficial to have a signal portal where information on the contamination of food products with radionuclides can be published. The European Radiological Data Exchange Platform could be utilized for atmospheric air radiological monitoring data, making the information readily available for public use, scientific research, and public awareness. This approach would enhance the effectiveness of radioecological monitoring efforts. Thank you for your attention.